right, so today we're going to take a look at graphing cube root functions. So far we've talked about linear, exponential, quadratic. We've even talked about square root functions. Now we're going to take a look at cube root functions. Now, one of the things we want to do when graphing, if I have the function y equals the cube root of x, I want to plot values that are easy to graph. So with that being said, I want to make sure I pick perfect cubes here. So the cube root of 8 is 2, cube root of 1 is 1, cube root of 0 is 0, cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So that when I plot those, I'm going to have, if you notice, this is kind of like half a cube root. This is actually a square root function. And then this one is kind of the opposite of that function. So let's take a look. So what's going to happen if we change this? Now, the neat thing about this is the same rules apply for vertex form, for cube roots, all of these other functions that we've been dealing with. So if I have the cube root of x plus 6, this is outside that root function, this is going to tell us that it's a vertical translation 6 units up. Now, I can also pick points to graph that. Again, I'm looking for perfect cubes here. So the cube root of 8 is 2 plus 6 is 8. Cube root of 1 is 1 plus 6 is 7. Cube root of 0 is 0 plus 6 is 6. Cube root of negative 1 is negative 1 plus 6 is 5. And the cube root of negative 8 is negative 2 plus 6 is 4. So we have our original function here. So I have 0, 1, 1, negative 1, and let's see, 8, 2, negative 8, negative 2. So the best way to draw this is to kind of draw it into two parts so it looks like that square root function. So this is y equals the cube root of x. Now I have these points. So I have 8, 8, 1, 7. Whoops, I'm off by 1 here. So let's see, let's do it this way. I have 0, 6. I can kind of figure out my points just from here. So I've got this function here, this function here. So I have y equals the cube root of x plus 6. Notice vertical translation, 6 units up. Now, what's going to happen if we have a negative cube root of x plus 4? Now, we're still comparing it to the same parent function. So this here is inside those parentheses or inside that radical. So think about it that way. So this means it's going to shift horizontally. And remember, it's x minus h. So that's telling us that our h is a negative 4. So it's going to be a horizontal translation, 4 units left. So horizontal translation, 4 units left. But I also have a negative out front, so that's going to tell me it is a reflection in the x-axis. So let's take a look at this on a graphing calculator. So I have y equals, let's graph our parent function. So I have this, I have the square root of x. Then, I don't want the square root, I'm sorry, I want the cube root. So I'm going to go to math, cube root, x, enter. Then I'm going to do, negative, cube root, x, plus 4, graph. So here's my parent function. Notice there's the shift and it inverted, so it flipped. So this flipped upside down and it shifted 1, 2, 3, 4 to the left. So for here, I'm going to write C graphing calc. Now, let's take a look here at this one. So we've got a lot going on here. So I have 3 times the cube root of x plus 1 minus 2. Look how similar this looks here, okay? So this is telling us that this is a vertical stretch by a factor of 3. This is a horizontal translation, 1 unit left, and this, our K, is the vertical translation 2 units down. Again, we can graph those if you'd like. So take a look and see what those look like. So I'm gonna go y, I've already got my parent function, so here I'm gonna do 3 x plus 1. Make sure you hit that arrow over, otherwise it's gonna be within the radical, and graph it. There's my parent function. So it's stretched. There's a little break right there. Calculator does some weird stuff sometimes, but we have our graph. All right, looking at example 4. Now, what I want to do is find the average rate of change between this graph M at x equals 0 and x equals 8. So if you remember, rate of change, I'm looking for slope. And I'm looking for it at x equals 0 and x equals 8. So right here I have 0, 0, and 8, 8. So line M, I want change in y over change in x. So I've got 8 minus 0 over 8 minus 0. So the slope of that line is 1. Now I want to look at this one, but I'm still using, now remember this is just average rate of change. Clearly, I'm just looking at these points and that's a line, but remember, we've got a different function here, so we're just looking at an average, not the actual. So now, I want to use 0 here and 8. So h of 0, cube root of 2 times 0. So the cubed root of 0 is 0. So this point is also 0, 0. Now here, this one's not quite as pretty. So I have the cubed root of 2 times 8. Now that's going to give me 16, but I still need to simplify here. So the cube root of 8 is 2. So I have 2 times the cube root of 2. Okay, so this point right here, so this is, I now have 8 and 2 cube root of 2. So now what I want to do is find my slope. So I have 2 cubed root of 2 minus 0 over 8 minus 0. So I have 2 cubed root of 2 over 8. Now that's going to give me an approximation here. So let's see, let's do some math. So I've got, let's do parentheses here, 2, oops, that looks like a 3 or a 2. 2 cube root of 2, arrow out, divided by 8 gives me approximately 0.3. Now, it says graph the cube root function m. Now compare these. So I need to compare these to these. Now I'm going to do that by figuring out how many times greater. So my answer here is 1 divided by 3/10, which gives me approximately 3 3/10. So what am I going to label this? So that means I've got 3 3/10 times greater than the average rate of change of h of x. So that m is 3 3/10 times greater than the average rate of change of x.